All right, everybody, welcome back. Today we are again talking about moving charge in a magnetic field, but we're going to be doing some more calculations and introducing a formula to, help us understand this more. So here's the formula. The force on a charge from the magnetic field is equal to the charge, how big the charge is, and kind of like how we learned about before, the bigger the charge is, the more the forces there's going to be. The velocity of the charge, and like we learned about before, the faster it's going, the more the force is going to be on the charge. And the magnetic field that's perpendicular. The stronger the magnetic field is perpendicularly, the more it's going to have a force on the charge. Okay, we kind of touched on this a little bit, but now we have our formula. And this is how it looks like. Force is equal to QVB. F symbolizing force in newtons, Q being charge in coulombs, V being velocity meters per second, B as a magnetic field, Tesla. Okay, and here are the other ways to manipulate the formula. All right, let's get to it. Okay, so we have an electric charge of positive 0.02 coulombs is moving at a speed of 280 meters per second downward through a magnetic field of 0.43 Tesla that is pointed out of the page or screen. What is the magnitude and direction of the magnetic force? Okay, so first let's just look at the mathematics. Okay, the force is equal to QVB. If you remember from the formula, QVB. And remember, this B has to be perpendicular. Okay, the magnetic field has to be perpendicular. Okay, so for the charge, 0.02, velocity, 280 meters per second, and the magnetic field, 0.43. Okay. Okay, so we can see that it is perpendicular because the charge is going down while the magnetic field is pointed out of the page. So one's going down, and one's going out of the page. So they make that perpendicular. Okay, so now let's calculate this. 0.02 times 280 times 0.43, and we get 2.41 newtons. Okay, but now let's see which way is this force going. Okay, so this is a positive force. So I'm pointing down this way, and the magnetic field is pointed out this way, so that's the way I'm going to put my fingers, going out this way. So now you can see my thumb, it's pointed to the left. So it's going to be 2.4 newtons to the left. So moving down, that's my right hand rule. My curled fingers are going to be pointing in the direction of the magnetic field, which it says pointed out. And my thumb points in the direction of the force, which is going to the left. So then we have 2.41 newtons to the left. All right, moving on. And don't be afraid to look silly moving around when you're doing the test or quiz. That's how you're going to get the good grades. All right, here we go. An electric charge of negative 0.007 coulombs is moving at a speed of 320 meters per second to the right, experiencing a force of 29 newtons upwards. What is the magnitude and direction of the magnetic field? Okay, so first let's just do solve for the problem. We have force is equal to QVB, as long as this is perpendicular. And then we're looking for the magnetic field this time. So I'm going to do the magnetic field is equal to force divided by QV. Just did a little bit of simple manipulation. So B is equal to the force, which they give us 29 newtons. Then the charge, which is 0.007. And then how fast it's going, 320 meters per second. Okay, so let's calculate this. 29 divided by 0.007 times 320. And we get around 12.95 Tesla. Okay, so now let's kind of look at everything. Well, we can see that this charge is going to the right. And then we can see that the force is upwards. And then that's going to tell us, okay, it's going to the right, force is upwards. That means the magnetic field is going to be pointing in towards us. However, a big thing we should know is that the velocity, the charge is negative. So that means everything's going to be upside down, meaning if the electric field is supposed to be pointing inwards, it's going to be the exact opposite of that. It's going to be going 180 degrees the other way. And another way to think about this is, actually, no, I don't want to change anything. But remember, it's the opposite when it's negative, okay? When it's a negative charge. So even though if it was a positive, it'd be going inward, the magnetic field. But since it's a negative, it's going to go the other way. Okay. So 12.9 Tesla out of the screen. Okay, moving on. Good demo. And here we go. Another negative example. So hopefully we do all right with this. An electric charge of negative 0.004 coulombs is moving quickly to the left through a magnetic field of 47.2 Tesla, going downwards. Okay, it experiences a force of 31 newtons. How fast is the charge moving? What is the direction of the force? All right, again, formula. Oops, not Q. Force is equal to Q, B, B. And this time we're looking for the velocity. So we know velocity is equal to force divided by QB. Velocity is equal to force, 31, divided by Q, 0.004 times the magnetic field, 47.2. Now let's put this in my calculator. 31 divided by 0.004 times 47.2. And we get 164. Whoopsies. 0.19 meters per second. Okay. What is the direction of the force? Okay, so let's again look at this. Going straight down there. That's the velocity of our charge. Magnetic field is going down, so going down like this, and that means my thumb is going to be pointed outside the screen. It's going outside the screen like this. However, again, it is negative, so it's not going to be pointing outside the screen. It's going to be 180 of that. It's going to go inside the screen. So it's going to be into the screen. Right? Moving on. A positive charge, okay, positive, everything is normal again, is going up at a speed of 218 meters per second through a magnetic field of 51.8 Tesla going out of the page. Screen. Screen. It experiences a force of 44 newtons. What is the magnitude of the positive charge? Okay, let's look at this. We have force is equal to QBB. Okay, so we can now say charge. If we manipulate this, equals to force divided by VB. Q is equal to force, 44, divided by the velocity, 218, times the magnetic field, 51.8. 44 divided by 218 times 51.8. And we get this charge is equal to 0.0039 coulombs. Okay, and what is the direction of the force? Okay, so going up. Okay, magnetic field is going out of the page, so that means we're pointed out this way. Okay, coming towards me. And that means my thumb is going to be pointed to the right. So the force is going to be going to the right. Okay, hopefully we're getting pretty good at this. All right, that's pretty much it. Next time we're going to be talking about how a current is affected by magnetic field and things like that, which is actually a little bit easier than charges. So hope to see you with that. Thanks for watching, everyone. Bye.